Yo kids, here we go. 2016 Physics P1 paper, Unit 1, my unit. Let's have a look what's going on. Question number 1, it was the uncertainties question basically. And it was wrapped around density. They give us a volume of a ball bearing. They give us a mass of a ball bearing. And they want us to work out the density of the ball bearing. So density is mass over volume. So that's pretty easy. Chuck those numbers in your calculator. 8.1 grams per centimetre cubed. Then it's to show that its percentage uncertainty is about 5%. Okay, so to get the volume uncertainty, get this 0.2 divided by the measurement of 5.6, turn that into a percentage. That's 3.6%. Get the error in the mass, 0.5 divided by the measurement, turn it into a percent. That's 1.1%. And of course add up these uncertainties to get the total percentage uncertainty for the density, which is 4.7%, which is close enough to the show me 5%. Determine then that as an absolute uncertainty means basically get your answer for density and find 4.7% of it, right? So we worked out the density was 8.1 grams per centimetre cubed. 4.7% of that 8.1, type it in the calculator, is 0.38, right? So that's the absolute uncertainty. So you could think of the density as being 8.1 plus or minus 0.38 grams per centimetre cubed. Right, nothing too tricky there. Then they give you a table of some possible densities for different materials and alloys, and they're going to ask us basically, I think, to figure out which one of these it is based on our results, right? It says, write down the possible materials that the ball bearing could be made of. Now, of course, we worked out the density as being 8.1 plus or minus 0.38. And if you look at these values there, 3 of those materials, or metals I should say, come in that category of going down from 8.1 take away 0.38 to 8.1 add the 0.38. And those 3 materials were iron, brass or nichrome. They all lie within the uncertainty range, so we can't be sure which one it is. And then for the last 2 marks, identifying the correct material depends on reducing the uncertainty in the density. How do we effectively reduce the uncertainty in the density? Explain which one of the 2 values contributes more. Well, we proved it. The volume contributes more. They're of the same power, right? It's mass to the power 1 divided by volume to the power 1. And the percentage of volume uncertainty was 3.6, which is more than 3 times that of mass. So we need to work on getting a more accurate value for volume. The volume, it has a much higher uncertainty than mass. What a brilliant 8 marks to start the paper that was. Right, see you at the next one.